Before we get into the lesson for today, which, by the way, is the last lesson of the year. This is the last time we're going to take notes in here this year. I know it's kind of sad, but you'll get over it. I want to go back to this equation from the opener and talk about it real quick. So it's important to understand the idea of what's going on here. We have a number which is represented by this variable d times another number which is represented by this variable e. And when I multiply those two numbers together, we get 0. So what did we say is going to happen with either d or e to make this equation true? One of them has to be 0, right? So no matter what one of the other one is, if we say d is 0, then the other one can be anything we want, and this will be true. So 0 times anything is 0. Or if we say e is 0, then this equation has to be true also. So anything, whatever d is, times 0 is 0. So one of the two has to be 0. It's possible for both of them to be 0. But whenever we multiply two things together and get 0 as the answer, one of the factors, one of the things that we're multiplying has to be 0. All right, and that's going to be the key. That's what's going to make allowing the equations, allow us to solve the equations that we're going to see today. All right, so here are the steps we're going to take. Let's write those down first, and then we'll just go through and go through the steps as we do each problem. The first step is actually something you're not going to have to do. You still need to write it down, but we're going to do that step for you when we give you the problems. But we're also going to have to factor, and then the step 3 is the trick here that we're going to use from that last equation there. So go ahead and get that written down, and then we'll use that to go through a few examples. All right, so here's our first example. This example right here is actually the equation that we did yesterday that we had in our opener, and we decided we don't know how to solve it yet. We're going to be able to solve this using those steps that we just wrote down. So write this up underneath where it says example 1, and then let's just go through the steps. What does the first step say? So we're going to make sure the equation has everything on one side of the equal sign with the exception of a 0 on the other side. This is a step that we're always going to do for you. So when we're asking you to solve equations like this, it's always going to have everything on one side with an equal sign and then the 0 on the other side. All right, that's going to be done for you already. All right, step 2 says what? All right, we're going to factor this, and we're going to use the area model to factor it. Now, one thing that we need to make sure we do here when we're showing our work is we need to leave space underneath the equation here because this is the space we're going to use to actually solve the equation. So I'm going to do my MA work down here for the factoring. So I'm going to have M equals what for this equation? What's the first coefficient times the third coefficient? 6. Okay, 2 times 3 is 6, right? And what is A? 7. So we're looking for two numbers that multiply to get a positive 6 and add to get a positive 7. What's that going to be? 1 and 6. Okay, so those are the two numbers for our MA step. We're going to use that to help us with the areas. So let's fill in the areas now. What's the area of the first rectangle going to be? 2A squared. How about the top right one? 1A. How about the bottom left one? And the bottom right one? Okay. Now we need to find the GCF of the top row. What's the biggest thing that goes into 2 that also goes into 1? 1. And then what else do they have in common? A. That's going to be the height of that row. So the height is going to go inside of the rectangles also. So we'll put that here times the width, which we don't know yet, but we'll figure out pretty quickly here. And then 1A times the width there. Now, what is the width going to have to be in this top left rectangle to make the area of 2A squared? 2A, because we need that A to make the A squared, right? So we get 2A up top, and then the width of 2A down here also. What's the width of this rectangle going to be? 1. 1A times 1 is 1A. So we get a width of 1 there and a width of 1 here. And then hopefully our heights are the same here and here. What's the height going to be here? What do we multiply by 1 to get 3?
3.
Okay, what do I multiply by 2A to get 6A?
3.
So where else do I put that 3?
3.
Out on the outside, out front. Okay, so we've got our area model done, but we still need to write this. Now, in the opener, when we asked you to factor this, what we did is we wrote this, the area is equal to the height times the width. Well, we can't do that here because we have the 0 in the way. What we're doing here instead is we're going to say this area here, we're going to replace that with the height times the width. Since this is the same thing as the height times the width here, we're just going to replace it, and it's going to look like what? What's the height going to be?
1a plus 3 parentheses.
Okay, 1a plus 3. I'm going to leave the 1 off to keep it simpler, and I'm going to put it in parentheses. And then the width.
2a plus 1 parentheses.
Okay, now my goal here is to write an equation that means the same thing as this equation. So I need to make this an equation. So what am I missing here, Kiwana? An equals 0 here. Now, notice what we have at this point. We have a factor, a plus 3, times a factor, 2a plus 1, equals 0. So we have some number times some other number equals 0. Since we have two factors that are being multiplied together to get 0, this is some number times some other number equals 0. What's going to happen with these factors here? So since we have two factors being multiplied together to get 0, I know either the first one has to be 0, or the second one has to be 0, or both of them could be 0. That's possible also. So the next step in solving this equation says set each factor equal to 0. So the first factor is a plus 3. We're going to set that equal to 0. The second factor is 2a plus 1. We're going to set that equal to 0. And so I know one of these two equations has to be true because one of these two factors has to equal 0. And what I might do here is just put a little or in between to show that either this equation is true or this equation is true. Now let's go ahead and solve these. What am I going to do to solve this equation? Circle variable, draw the line, and then threes cancel, leaves a equals what? Okay, on the other equation, what are we going to do? Circle the variable, draw the line, and then what do I do first there? Okay. What does a equal here? What's negative 1 divided by 2? Trick question. It's negative 1/2. All right, so now the question is, which one's the right answer? We got two different answers. We got a equals negative 3 here, and we got a equals negative 1/2 here. Which one's the right answer?
What answer?
Let me ask this question. This is going all the way back to second and third triad when we were solving equations with squares in them. When we have an equation with a square in it, how many answers should we get? 2 answers, right? So which one of these two is the right answer? It's a trick question, right? They're both right. So either a equals negative 3 or a equals negative 1/2. So this looks kind of sloppy here. I'm going to rewrite it, but our answer is going to be, it's going to have two different answers in it. A equals negative 3 or a equals negative 1/2. If you remember when we solved equations by taking square roots, when we take the square root, we get either the positive 3 or the negative 3 if we're taking the square root of 9. So the same thing's happening here. We're getting two different answers. It's just not the positive and the negative that go with it this time. All right, so here's the second example. Let's just go through this one together, and then I'll give you time on the third example to see if you can get that one on your own. So the first thing I'm going to do is make sure that everything is on one side of the equal sign and 0 on the other. Again, that's done for you. We're not making you do that step. And then the next step is to factor it. So we're going to use MA here to factor. What's M going to be? 10. And then what is A going to be? All right, now what? So what two numbers are going to multiply to get a positive 10 and add to get a negative 7? Negative 2 and negative 5. They both have to be negative to multiply to get positive and to add to get a negative. All right, so let's fill in our areas then. The area of the first rectangle is b squared. The area of the top right one, negative 2b. The area of the top left or bottom left one, and the bottom right one, 10. All right, so now looking at the top row, what's the GCF of 1b squared and negative 2b? 1b squared and negative 2b is going to be 1b. That's going to be our height. So it's going to be 1b times the width. 1b times the width. What is the width in the first rectangle going to have to be?
1b.
1b. So that's going to be the width that we label up top and also the width of the rectangle below it. And then what do I multiply by 1b here to get negative 2b? Negative 2. So that's going to be the width that I label up top and also the width of the rectangle below that. Now, can I fill in the same thing here as I put in here? What's that going to be? Negative 5. So negative 5 times negative 2 is positive 10. Negative 5 times 1b is negative 5b. So we get negative 5 for our height here. Now, you guys may have noticed this in the opener also. When we have a coefficient, a leading coefficient or first coefficient of 1, then the two numbers that we get from our MA step are also going to be the two numbers that give us the area here and also the height here and the width here. Okay, that only works if the first coefficient is 1. If the first coefficient is something else, it's not going to work out that way. Okay, now we need to finish up factoring it. So we're going to write it as height times width. What's the height going to be? B minus 5 times the width. B minus 2. Notice that I left the 1's off. I'm trying to keep it as simple as I can so I don't have to deal with that stuff later. And then what do I need to do to finish this equation? Equals 0. Okay, that's step 2. That was a fun step, right? Now, step 3 is pretty easy. It says what? Set each factor equal to 0. So I'm going to take the first factor, the b minus 5, and say that equals 0. Then I'm going to say the second factor, the b minus 2. That could equal 0. So one of those two factors has to be 0 for this to multiply together to get 0. Then I'm going to throw a little or in there and solve each one of them by themselves. So circle the b, draw the line of equality. How do I get the b by itself in that first one? Add 5. When the 5's cancel, we get b equals 5. Okay. And then the other one, we want to get the b by itself there. What are we going to do? 2's cancel. We get b equals 2. And so we get 2 answers. Do we expect to have 2 answers here? Yeah, we should have 2 answers since the problem has a square on the variable. So we get b equals positive 5 or b equals positive 2, and those are the 2 answers that'll work. Now I just want to show you with this one because it's kind of easy to see. If I take either one of these numbers and plug it in for b up here, let's see what happens. Let's start with the 2 since that's a smaller number. It'll be easier to do. What's 2 squared?
2 times 2.
So what's 2 squared? 4. Minus 7 times 2. What's 7 times 2? 14. So we have 4 minus 14 is... 4 minus 14 is negative 10. And then negative 10 plus 10 is 0. So if I put 2 in, this equation works, right? Okay, how about 5? If I put 5 in there, what's 5 squared?
25.
Minus 7 times 5. What's 7 times 5? 35. Okay, so 25 minus 35 is negative 10 plus 10 is 0. So that one works, right? Do you think it would work for any number I plug in?
No.
Let's try a different one. Let's try plugging in 1. What's 1 squared?
1.
Minus 7 times 1. What's 7 times 1? What's 1 minus 7? Negative 6. Negative 6 plus 10? It's not 0, right? It's 4. So any other number besides these 2 that I plug in don't work. These are the only 2 that'll work in this equation. All right, I want you to give this one a try on your own. I will help you with the MA step though, because this one might be a little tricky. So go ahead and get the problem written down. Let's do the MA step together, and then I'll give you a little time on your own. M is going to be 126, negative 126. And then A is going to be negative 5. All right, now let's think about this. If we're multiplying two numbers to get a negative, then what's going to have to happen? One of the numbers has to be positive, one of the numbers has to be negative. And if we have a positive and a negative, we're actually subtracting to get a negative 5. All right, so let's just list factor pairs of 126. 1 and 126. That's not going to work. 2 and 63. That's not going to work. 3 and 42. Not going to work. 4 doesn't work. 5 doesn't work. 6 and 21. Does that subtract to get 5? 7 and what? 18? Does that subtract to get 5? Or negative 5? No? Okay, how about 8? 8's not going to work. 9 and 13? No, that's not right.
It's 14.
14, thanks. Does that subtract to get 5? That has a difference of 5, but which one is going to have to be the negative one?
9. Negative 14.
The 14 is going to have to be negative. Why? If we're going to add to get a negative number, which one has to be bigger, the positive or the negative? If we want them to add to get a negative number, the negative number needs to be bigger. Okay, so if they add to get a negative, then I make the negative number bigger. So it's going to be a positive 9 and a negative 14. So I've got the areas in here. As you guys do yours, I'm going to go ahead and do it also with a little bit of help from you. What's the biggest number that goes into 6 that also goes into 9? 3. So this is going to be 3c. That'll be my height here and my height here. What do I multiply by 3c to get 6c squared? 2c. So that's my width there and my width there. What do I multiply by 3c to get 9c? 3. So that's my width there and my width here. What do I multiply by 3 to get negative 21? Negative 7. And multiply by 2c to get negative 14c? Negative 7 also works. Okay, so when we factor it then, we're going to get what? What's the height going to be?
3c minus 7.
Minus 7, yep. And then the height, or the width, sorry.
2c plus 3.
Okay, and that is equal to 0. So now we're going to set each one of these factors equal to 0. We know that 3c minus 7 could equal 0. Or 2c plus 3 could equal 0. And then we'll solve each one of those equations. I'll tell you right now, we're going to get a fraction for both of them. So we add 7 here. 7's cancel. Leaves 3c equals 7. And then divide by 3. C equals 7/3. And then on the other one, we'll subtract 3. And then divide by 2. So we get two answers here. C could equal 7/3, or C could equal negative 3/2. And both of those answers are correct. It would not be nearly as fun plugging that in to check it here. We're not going to make you do that. But if I put 7/3 in here for C, and here for C, this equation would be true. Or if I put negative 3/2 in for C here and here, this equation would be true.